In experiment 2, we're going to use a Grignard reaction to synthesize triphenylmethanol. The Grignard reaction is one of the first non-trivial reactions that you will do in a lab. It's not necessarily the easiest reaction to make work. You've got to have a number of things done right. Most notably, you have to have everything dry. Now, remember that the first step in a Grignard reaction involves the insertion of the magnesium in between the carbon and the bromine. So if we begin with the phenyl and the bromine, and we react it with magnesium, as shown in the general scheme, we end up inserting the phenyl, so we end up with a phenyl, magnesium, and then a bromine. Because the phenyl is more electronegative, because the carbon is more electronegative, this is going to have a substantial minus charge, whereas the magnesium is going to have a substantial positive charge. In fact, I typically like to write it like this, where I show the phenyl having full control of the electrons and a minus charge, and then the magnesium having a plus charge, and drawing the magnesium bromide like this. Now, the first step is to form the Grignard reagent, and this is really the hardest part. Once we form the Grignard reagent, we can then add the diphenyl ketone, the benzophenone it's called. Now, again, we have a partial positive at the carbonyl, and the minus, the anion, will add in, pop these two electrons up onto here, and this is how we get our initially formed species, the phenoxide ion. Once this reaction is done, we'll quench by adding a little bit of acid, and that will get us to our final product, the triphenylmethanol. So let's begin with the formation of the Grignard reagent. We are going to measure out 0.74 grams of magnesium. Now we need to take a mortar and pestle and grind this up to make sure that we have fresh surface on it. What happens is that the magnesium tends to react with oxygen, and we tend to have a layer of oxide. So we're going to put this in our mortar and pestle, put the magnesium down in there, and then grind it up. You should be able to see a nice shiny surface. From here, we're going to add ether, and we're going to add the stir bar. Your flask should be oven dried. If it's not oven dried, then you'll want to flame dry it right off the bat. Water will kill this reaction, so you want to keep everything as dry as possible. Next, we're going to weigh out 6 grams of bromobenzene. We're not going to add this all into the flask immediately, but we're going to have it setting aside. For starters, we will combine the magnesium, 1 gram of the bromobenzene, and the stir bar. And we're going to begin to stir. I would recommend covering your reaction vessel with a piece of aluminum foil. I think would be ideal. Something that can keep the solvent from escaping, but something that's not going to build up pressure. So aluminum foil across the top lightly. We're going to then get the reaction started. Now you can usually tell if a Grignard reaction is taking off because you'll see little bubbles begin to form. You'll also see it begin to go kind of a murky gray, and you'll notice that the magnesium is starting to decompose, starting to disintegrate into smaller and smaller bits. So what you're watching for is for that heating to take place and that little bit of murkiness to start. If it really takes off, it will actually start boiling. The formation of the Grignard is exothermic. It just takes a little while for it to get started. Essentially, that magnesium has to have a fresh surface interact with the aryl bromide, but then once it starts to go, it goes really well. If you can't get it to start, which is a likelihood, a number of people will have trouble getting this reaction started, you can do a couple things. One, you can heat it up. Now, if you're going to heat it, you want to add the heating mantle, which is one of the kind of well-shaped mantles that will sit on top of the stir plate. Hopefully you can still have your stir bar stirring and be heating this way. If that doesn't work, we can heat directly from the heating mantle if need be. You definitely need to make sure your stir bar is stirring though. Another option is to add 1,2-dibromoethane. Now 1,2-dibromoethane, which is just this compound, tends to react really quickly with magnesium. It's great for sort of jump-starting the reaction. Now it's going to consume some of your magnesium, and it's going to give you a little side product Grignard reagent. So you don't want to add much if you do this. Maybe add a drop or two to see if you can get it to go. Hopefully your reaction will go just by heating gently. Once the reaction starts, once you're seeing bubbles, you're seeing that little bit of gray murkiness start to form, then you want to get the reaction to go the rest of the way. So go ahead and slowly add the rest of your bromobenzene to this, and it should continue to consume the magnesium. You want to probably heat this and stir this for about 15 minutes at least to make sure that your magnesium is consumed. It won't totally disappear. You'll still have, because you have an excess of magnesium, you'll still have a little residual magnesium floating around, but you'll have the sense that the reaction has gone. Once you've formed your Grignard reagent, so you now have this murky gray solution down in here, and you've stirred it for about 15 minutes. Most of the magnesium is gone, although there will be little bits still floating around. You now want to begin to add your benzophenone. Now, this is an exothermic reaction, so add it slowly initially. It can take off on you if you're not careful, so add this dropwise. To add this dropwise, I would encourage you to just take a little pipette and add it drop by drop through the top of the funnel. It'll work its way down and drip on down in there. Now, some of you might run into a situation where the ether begins to boil off and you feel like you need some more ether. If you do that, the most important thing is to remove the heating source. We had a fire a couple of years ago where someone needed to add more ether, but they still had their heating mantle down here. They tried to add the ether squirted, shot down the side, hit the hot plate, and burst into flames. We're going to try not to do that. So remove the heating mantle before you get started with that, and that will circumvent that problem. You won't have as much problem adding the benzophenone for a couple reasons. One, it doesn't have as high a vapor pressure, so it's not going to squirt out of the dropper, and two, it's not nearly as flammable or explosive as ether is. So you'll be fine to add the benzophenone, but if you need to add the ether, remove the heat source, please. Once you've completed your addition, you can heat to reflux for another 30 minutes. And that will, and then you will have formed your alkoxide and you're ready to work it up. In the workup, we're going to cool to room temperature, and then we're going to add water and actually dilute acid to quench this reaction. So the water will protonate. The dilute acid will also consume any of the remaining magnesium. So drop by drop, add in a little bit of water, let it continue to stir. As it begins to stir, you'll notice a second layer forming. The lower layer will be your aqueous layer, and you should see all of that magnesium be consumed because it's dissolving in the aqueous acid to form magnesium chloride. Once it's done this, then you can transfer to a separatory funnel. Now on the separatory funnel, you'll again have two layers. Your lower layer will be your aqueous. Your upper layer, your ether layer, should be the organic. Don't throw anything away until you make sure that's the case, but that's probably what it's going to look like. You want to drain off your aqueous layer, set it aside, and then take your organic layer and drain it into an Erlenmeyer flask. You can then dry the layer using sodium sulfate, and then we're going to rotovap this down. Now, when we rotovap it down, we're going to take it down to about 2 mils of kind of an oily liquid. So we're going to get rid of the ether, but we're not going to get rid of all of the bromobenzene in the process. In order to do this, we're going to add in some hexanes into the round bottom flask and stir it around. Now what's going to happen is that the hexanes will dissolve up the bromobenzene real easily. it doesn't dissolve the triphenylmethanol nearly as easily. And so what will happen as we add hexanes, we'll see crystals begin to form. That oil will be taken up and crystals will begin to, or a solid will begin to precipitate out. We can decant the hexane layer and then add some fresh hexane in, swirl it around. You'll see that yellow color kind of be taken up out of the solid. And after 2 or 3 washings with hexanes, you should have a mostly white solid. And that's going to be almost entirely your triphenylmethanol product. If you have enough material, you can then recrystallize from ethanol. And then once we've recrystallized and dried, we can analyze by NMR and IR. We can do this all in 1 week if we have enough time. If we're pressed for time, we can do the NMR and the IR the subsequent week.